हेलो डियर स्टूडेंट्स। कैसे हैं आप सभी लोग। आई होप आप सभी बहुत अच्छे होंगे और बहुत मेहनत कर रहे होंगे। सो टुडे वी विल सॉल्व those questions from the chapter unit and dimension which have been asked in previous year NEET exam. So let's start solving all these questions. I have already given you the PDF of these questions as in the form of test. So I hope you have attended, and if you have not attended it yet, then just look at the distribution, look at in the description. I have given the link of my Telegram channel where you will find all the lectures of the videos of unit and dimension which I have uploaded here in the series. So go give the test, because although questions are not so difficult, and you will get an idea how question have been asked in NEET from these chapters, and yes, you will gain confidence. Maybe you will not need to solve all the question, but yes, taking a look will give you confidence. And after that, you can come here and you can watch all the questions, or whatever question you find you should be seeing the solution of. Or if you want, you can just uh, go by looking these videos, watching this video. One by one, you attempt questions and then you wait for the solution. Okay, students. So, in the last, you will see the answer key also. Let me show you. This is the answer key if you want to check. Yes. So, one by one, you can go and you can just check if your answer is right or wrong. Okay, students, let me start. So, the first question is the velocity. This is really easy question. It is asked in AIIMS 2006. The velocity v of the particle at time t is given by v is equal to this. Okay. So what is the dimension of A, B, C? We will solve this question using principle of homogeneity of dimensions. And what does it say? It say that the dimension formula on the left hand side of the equation should be equal to dimension formula on the right hand side of the equation. That is LHS dimension formula or dimension of physical quantities or base quantities on left hand side is equal to dimensions of physical quantities on right hand side. That means dimension of velocity must be equal to dimension of at plus this whole thing. You must also know that all the additive terms in an equation must be having same dimension formula, because only the physical quantities with same dimension formula can be added or subtracted. That means this term at and b upon t plus c, this both term must have same dimension formula. So I can write this is equal to dimension formula of a into t, and this is equal to dimension formula of b by t plus c. Also, one more point that we can see, in the denominator we have t plus c, so t and c are both additive, so they can only be added if dimension formula of t should be equal to if dimension formula of c is equal to dimension formula of t time. So that means dimension formula of c is equal to dimension formula of t, and t is time. So dimension formula of c is equal to t to the power 1. So I can simply write it as b by t, because t plus c will be having same dimension as t. So why to write c? So now, to find dimension formula of A, I will just use these two terms. I will write dimension formula of A is equal to dimension formula of velocity, that is Lt minus 1 divided by t. So I will get Lt minus 2. Now in order to calculate the dimension formula of B, I will use the first and last term. So dimension formula of B will be equal to dimension formula of V into dimension formula of small t. And yes, you can guess now, LT minus 1 into T, and I will get L. So this is how I calculate dimension formula of A, B, and C. So this is a really easy question, but yes, you will learn all the concept related to principle of homogeneity of dimension in this question. Now, dimension formula of electrical resistance. To find the dimension formula of electrical resistance, you must know at least one formula in which resistance appear. So I can remember V is equal to IR, the famous equation, Ohm's law, or I can also use power is equal to I square R, because then I can directly write power divided by I square, and we know power is energy upon time. So dimension formula of power will be, so dimension formula of resistance will be dimension formula of power, that is ml t minus 3. So you must know how to write dimension formula of power. It's just mechanics. Divide by m current is a base quantity, so it's ampere square. So finally you can see this is the dimension formula. You just take m a square on in the numerator, so we will get ml t minus 3 a minus 2. This is how you solve the question. Yes, so you match answers, because I'm not going to waste my time. Not mine. I literally like to keep videos short, but also I like to explain all the points, so that uh, we cannot say which point will become uh, beneficial for which students. So I don't want to miss out any point. But yes, checking answer is your task. Go and check it. Okay, students. So let's move forward. Now, which two of the following five physical parameters have the same dimensions? Okay, so same dimensions. Mm, if you like to study all the concept with interest, with some dedication, then you must have probably heard this term energy density, and you must also know that energy density, that the unit of energy density is same as that of pressure. But it's not really difficult. Energy density, if you want to find energy density, that is energy per unit volume, right? So U upon V, energy per unit volume. So energy, that is ml square t minus 2 divided by volume L cube. So we can see here we are getting ml. I'm not going to cancel L square completely. I'm just cancelling one L each from numerator and denominator. So I will get mlt minus 2 divided by L square. So it's looking like force upon area, that is pressure, right? So dimension of energy density is same as dimension of pressure. And also, if you are confident in elasticity, then obviously you will know that dimension formula of Young's modulus is same as pressure, and is same as stress. So we know that stress is equal to force upon area, right? And we also know stress is equal to Young's modulus into strain. And you must know that strain is dimensionless quantity, because strain is changing length upon length. So yes, you can see that force upon area, that is pressure, okay, right? Pressure. So dimension formula of pressure is same as dimension formula of stress, is same as dimension formula of Young's modulus, right? And is same as dimension formula of energy density. Oh, let me write it properly. Yeah, this is how. So yes, you can say 1A and B are the answer. Okay, students. So let's move on to next question now. Now this is also a simple question. Actually, this is really a simple question, and all the physical quantities of which we have to find dimension formula are also simple. Force, we know that mlt minus 2. Pressure, we recently calculated m L minus 1 T minus 2. Force upon area, just multiply, divide by area, L square. Velocity L T minus 1, but write m to power 0, because anything raised to the power 0 is equal to 1. Acceleration is Lt minus 2, but don't forget to put m to the power 0 here. So now which is the correct statement? Mm, so I think this is correct. Second one. Now here the dimensions of half epsilon d square. Again, if you have studied well, or means if you are in the 12th class, then you must have studied this half epsilon e square is the energy density in the electric field. But yes, if you are in 11th class, if you just got into 11th class, then yes, then I will tell you how to find the dimension formula of half epsilon e square. For that, at least you must remember one formula, that electric field is equal to 1 by 4 pi epsilon naught q by r square, at least this. So here you can see that epsilon naught e epsilon naught e is equal to something like q by r square. Like I want to say dimension formula of epsilon naught e is equal to dimension formula of q by r square, because this 4 pi is a dimensionless constant. Now we can easily find out the dimension formula of q by r square, so we will leave it here. Let's solve for e only. So e, and if you know, then you can also calculate from here also. Also, you must know this force can be written as q into e. Force can be written as q into e. That is, so e is actually force per unit charge, F by q. So if you remember this formula, if you know this formula, then it is really easy. Or if you don't know, then also F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. So you can see that only difference between E and F is that in F there is one more charge, right? So from there also you can find this relation, and now you know that E can be written as F upon Q. So I'm just going to put this first. So half epsilon naught E square. So obviously half is a constant, epsilon naught E square. I will write it as epsilon naught E into E, and now epsilon naught E is Q by R square, and E is F by Q. Now you can see this F by R square, and now you are ready to find the dimension formula of half epsilon naught E square, and you can see force upon area, right? This is L square. I think let me write just this ml t minus 2 divided by L square, and we get, it is same as pressure, students. In I think which question, I don't know, second or third, this one, we here found all the relation between this dimension formula of stress is equal to pressure is equal to Young's modulus is equal to energy density. So now you don't have any confusion that this is pressure, L minus 1 T minus 2. Okay, so moving on to next question. Now this, see, if you can remember this, then remember that velocity of light in vacuum is given by 1 by under root of mu naught epsilon naught, simply. And so this is actually written this only, mu naught epsilon naught to the power 1 by 2. So obviously dimension formula of this is equal to dimension formula of velocity. So L T minus 1. 3 will be the answer. Now you may be thinking that if I want to, if I don't know this formula, then what? Then you have to solve for epsilon naught, then you have to solve for mu naught, and then only you may be able to solve this question. So for mu naught, right, for epsilon naught, it's not a big deal because you know epsilon naught. Now for mu naught, you will be able to solve this question better if you are in the 12th class, 12th standard, because then you must have already studied this formula, and then it will not be difficult for you to choose the right formula. So I would choose mm, like uh, like energy density U upon volume is half epsilon naught E square, right? And we know that this is same as pressure. So anytime we can do. Also, similarly, energy density in the magnetic field is given as B square by 2 mu naught, right? Mu naught. So here also you can see you can do something like if I just equate, we know that dimension formula of this is equal to dimension formula of this. So I'm just going to put this dimensional formula of half epsilon naught E square, that is epsilon naught E square electric field is equal to B square by mu naught. At least we are getting close. We have got a term which is similar to what is being asked, the same as what is being asked to us. Now this is B by E, right? So now if you know, because if you are in 12th class, then only you will be able to use all this formula. You must know that force is equal to QV cross B, and also this force is equal to Q into E. So I think now you have got how to solve for let me just equate these two equations. So I can say that E is equal to V into B, right? Or I will say that B by E is equal to B by E is equal to 1 by V. So here this is a square, right? So I am getting 1 by V square, and I think this is all. From here you can go here. So you will be able to solve this only if you are in the 12th standard. Okay, fine. Now moving on to next question. This is a really good question. You must know how to solve this question by this time. But if you still have any confusion, then how do you solve? Here they have said that energy, velocity, time are chosen as the fundamental quantities. The dimension formula of surface tension. Okay, so okay. Now surface tension. Either you must know the formula or you must be in 12th standard. Hmm. So energy density. They are asking the dimension formula of surface tension, means they are actually asking the relation between surface tension, energy, velocity, and time, or the expression for surface tension. So I will write surface. I will say surface tension as S. So surface tension is proportional to, I will say, E to the power A, V to the power B, and time to the power, sorry, I will use T only, time to the power C. This is how. Now you must know surface tension is force per unit length. Force per unit length. So force is mLT minus 2. So ml divided by L, it's gone. So what I'm doing is the dimension formula of this is equal to dimension formula of all this. And we know that the constant which comes if when I will remove this proportionality sign, then one constant will come, and you must remember that those constants are dimensionless, always dimensionless. So here E is energy. I will write ml square t minus 2 to the power a, velocity lt minus 1 to the power b, and t to the power c. Now m to the power 1.
and here we are seeing m to the power a, right? Here t to the power minus 2, and here l to the power, oh okay, first I will write t to the power minus 2a minus b plus c. Now l to the power, here l to the power 0, and here l to the power 2a plus b, like this. So a is equal to 1 I will get from here. Also I will get this 2a plus b is equal to 0, is equal to 0. Now this is here 2a minus b plus c is equal to minus 2. This is how. And after that you have to solve, uh, as you know, 2a is equal to 1, so you have got b here, b is equal to minus 2, right? This and now you have to solve for c. I will write minus 2 uh, plus 2, okay, plus c is equal to minus 2. So here what I am getting, minus 2, okay. So let me just put it. So s is equal to some constant time, obviously this constant k is dimensionless, e to the power 1, and v to the power, v is velocity, right? Yes, okay. V to the power minus 2 and t to the power also minus 2. This is how, whichever is the correct option. I think this is it. Second option. Okay, again in 2015 PMT happened twice actually, because in the first attempt there was uh, some problem, maybe some cheating happened. So students, now in this question, if the dimension of a critical velocity Vc of liquid flowing through tube is expressed as Falana Dimka. Actually, they have said this critical velocity means you should not be reading or trying to understand the story. They only want to show that velocity, that physical quantity, depends on eta, that is coefficient of viscosity, rho is the density, and r is the radius. This is all. This is all. So v is depending on. So I will write eta to the power x, rho to the power y, and r to the power z. This is how, right? So this is the function of velocity, and now you must know what is the uh, dimension formula of eta at least, in order to solve this, because what you are going to do now is dimension formula of v is equal to dimension formula of eta to the power x, and dimension formula of density to the power y, and dimension formula of r to the power z. This is how. Now in order to find dimension formula of eta, you must at least know any other formula in which eta appears. So yes, we have one more formula, that is force of viscosity between the plates. So F is equal to eta a dv by dx. This is one formula where you also see coefficient of viscosity. So from here coefficient of viscosity will be, let's see, dimension formula will be F. Now here dx upon area into dv, like this. Now dimension formula I have already used whole space, so I will try to use minimum space because we have to solve this question also. So dimension formula of eta is going to be dimension formula of f, that is mlt minus 2. Dx is L divided by area L square, and dv is lt minus 1. So we can see here this is all cancelled, and I am seeing this m, L to the power minus 1, t to the power minus 1. Okay, fine. Now we will start solving. Dimension formula of V is LT minus 1 is equal to eta ml minus 1 t minus 1 to the power x also. Now density we know that ml minus 3 to the power y, right? And r is simply l to the power z. Now you have to solve. Here you may not be seeing exactly m, but n to the power 0 is here. So I will now see this. So m to the power is here, m to the power is x, here m to the power y. So I will write x plus y is equal to 0. Now comparing the powers of l on both side, l to the power 1, here minus 1 and here minus 3. Okay, so minus 1 into x minus x minus 3y and z. So here I can write minus x minus 3y plus z is equal to 1. Now again, similarly, let's do for time. Minus 1 is equal to minus 1 into x, so minus x will come, minus x. Okay, okay, so there is no other term of time, so I can write minus x is equal to minus 1 and simply x is equal to 1. Here we got x is equal to 1. Okay, so now we can simply solve. X is equal to 1, so from here we can write y is equal to minus x, that is minus 1. And now as we know x and y, I think you can also find for z. This is how you solve question. Now students, I expect you to solve this and match the correct option. Now again students, this is the question you have been asked. Oh, what is the story? Let's read. Planck constant, speed of light. Planck constant, speed of light in vacuum, that is speed, and Newton's gravitational constant g are three fundamental quantities. Okay, so they are saying that choose these as fundamental quantities. Which are the following is the correct combination for the, or which are the following combination of this has dimension of length. So actually they want to find expression of length in terms of Planck constant, speed of light, and gravitational constant. So let's find out the formula for length. Length proportional to Planck constant to the power a, velocity to the power, that is c to the power. I will use velocity, or let's use different variable x, c to the power y, and g to the power z. Now you must know that what is the dimension formula of Planck constant. So if you don't remember, as I also don't remember it, I simply know the formula where it appears. So E is equal to h nu is the famous equation. H nu, this is not velocity, this is frequency. So frequency, we know that it is 1 by time. So dimension formula of h is equal to energy into time, like this. Energy into time. Frequency is 1 by time. So here energy, we know that ml square t minus 2, but into time, then I will get t minus 1. This is the dimension formula of S. And now the question is not really difficult. Dimension formula of L, that is capital L, is equal to whatever constant will appear in place of proportionality constant, that will be dimensionless. Now Mm, h to the power x, so ml square t minus 1 to the power x, and cl t minus 1, that is velocity, to the power y. And you must remember now dimension formula of gravitational constant, students, because this formula appears so many times. Force is equal to g m1 m2 by r square. So this r square is going to be multiplied by f, so there will be l square, right? And g m1 m2 m square will come down. So I'm just writing the formula, that is m minus 1 l cube t minus 2. Let me write it properly. Minus 2 to the power z simply. Now I will simply compare powers of m, l and t. Here n to the power 0 and l to the power 1 and obviously t to the power t to the power 0. So I will simply write the equation and then you solve it completely. Here I will write m to the power x, m to the power x, m to the power so x minus z, and here no m, is equal to 0, that is x is equal to z. Now t to the power 0, so minus x minus y and minus 2z. So minus x minus y minus 2z is equal to 0. Also again you will see 2x here, 2 and x here 1, so 2x plus y, 2x plus y, and here in the last 3z is equal to 1. And now I expect you to solve this equation. Now here also this question looks really scary, but don't be scared, my dear students. This e square upon 4 pi epsilon naught is nothing. Force is equal to what? Force is equal to q1 q2 by r square, q square by 4 pi epsilon naught r square. So it is simply this. Dimension formula of this is equal to dimension formula of this, and actually this is nothing but ml cube, because mlt minus 2 is the dimension formula of force. So ml, and here we are multiplying l square, so ml cube t minus 2 simply. So we know the dimension formula of this term, we know dimension formula of g. If you don't remember, I just derived it the last question, that is m minus 1 l cube t minus 2. Now again dimension formula of c you know, and what they are asking, physical quantity having the dimension of length. Okay, so they want dimension, they want length in terms of these quantities. For a minute I am going to write this as k. This is simply just to avoid our labor. So L is proportional to, I will write c to the power a, c to the power a, not I now I will use c to the power x, g to the power y, and this term k to the power z simply. Now we know the dimension formula on the both side will be same, so L is equal to lt minus 1 to the power x, g you know m minus 1 l cube t minus 2 to the power y, k you know this k we just found out, m l cube t minus 2 to the power z, right? Now just solve it, students, just solve it. This is not really big. Thermal conductivity, again in order to find unit of thermal conductivity you have to find, you must remember a formula in which this appear. Now you must remember that formula correctly, obviously, otherwise you will get it wrong. So if you remember that in thermal conductivity chapter, the rate of heat transfer, that is power, is equal to Ka delta T by delta X, where T is temperature here, students. D is temperature. Sometimes they use theta instead of T, just for removing confusion. So power, now you must bring everything no unknown one side and everything known on the other side. So here this will become power into delta x, and in the denominator we will get area and this delta t. Now change in temperature and temperature both have unit of k only. Now finally I am writing dimension formula m l square t minus 3, area l, sorry, delta x is length, area l square, and this is temperature. So temperature for temperature sometimes they use theta, sometimes they use Kelvin also, K also. So I will use this K only, no problem. Now it's just over. So I will simply write M L T minus 3 and K minus 1. Now this is dimension formula. Okay, they have asked no for they asked this unit. So you can also write unit also, but they asked unit in terms of joule watt like this. So it was not that difficult, students. I found out the dimension formula. So power is just I'm using this here. Just put in this equation just put their units. So I will write watt into meter. I'm writing SI unit, meter divide by meter square, and here I will get Kelvin. So we can say we got watt mhm, watt meter minus 1 Kelvin minus 1. So this is going to be the answer. So watt meter minus 1 Kelvin minus 1 is answer is 4. I think students you all got the answer correctly. So with enough practice you can solve each of this question within 30 seconds. Okay students, I hope you have gained some confidence. Likewise I will put uh, like this MCQs from all the chapters in the end of the lectures, video lectures, concept based video lectures. So stay tuned students. If you are new to this channel, do subscribe, and also tell me in the comment how did you like it. And okay students, happy learning.